So in these videos, we're going to talk about radian measure. So this video and a couple other ones. So before we can actually start to use radian measure, we actually want to talk about what radian measure is and where does it come from. And so radian measure is the preferred mathematician way to measure angles. So radian measure is the preferred way to measure angles. And so the thing that happens with radian measure is 1 radian is the angle that intercepts an arc equal to the value of the radius. So if you have a circle, and here's the radius of my circle, and so if I want to draw an angle, let's say this is my angle, and we're saying that this angle theta is 1 radian, what that would have to mean is that this part of the circle here would also have to be equal to r. And so from that, we can actually come up with a conversion factor, but to do it, we have to remember a little bit about arc length. So the thing to remember about arc length, so arc length is always equal to r times theta. So in general, arc length, right, is r times theta. So it's r times theta. So again, if we go back to a circle and we think about taking a whole entire circle, right? So I have a whole entire circle. So a whole entire circle is 360 degrees. So when we go to determine this radian measure, we're going to have to start with that 360 degrees. So we have 360 degrees. And remember, here I said arc length is equal to r theta. So the arc length of a whole entire circle, if I take a whole entire circle and I go all the way around the outside like this, right? Remember, that's just the circumference. So that's 2 pi r. So my arc length here, let me erase this 360. So if I kind of fill into my formula here, the arc length of a whole entire circle with a radius r is going to be 2 pi r. And remember, that is going to equal to r times the degrees. And when you talk about a circle, it's 360 degrees. And if you notice, there's r on both sides of my equation. So I could divide both sides by r. And what ends up happening is they cancel out. And we end up with 2 pi equals 360 degrees. Or we could divide both sides by 2. And we end up with pi equals 180 degrees. And so you might go, okay, what does all that mean? All that means is what we're saying is the conversion factor we're going to use to go between degrees, like we're used to, and radians, is that 1 degree, or not 1 degree, sorry, is that 180 degrees is equal to pi radians. Now, we usually don't write out radians. We have that symbol for degrees, but we don't have a symbol for radians. So when you see an angle and there's no degree sign, we're just going to assume it's radians. So everything I did so far was just to kind of show you what radians are. This is the most important piece and the only piece you really need to know, and is that conversion factor. So for example, if I want to convert the following angles to radians. So for example, suppose we take 30 degrees. So I want to take 30 degrees, I want to convert it to radians. So remember, I have this conversion factor, so that's what I'm going to use. So I'm going to multiply by the 30, I'm going to multiply by pi radians over 180 degrees. And notice I didn't write the radians part. And if we do that, so in this case, we're not going to like divide it out on a calculator. Your answers are going to potentially have pi's in them. So the degrees would cancel. 30 goes into 180 6 times. Right? So once goes into here 6 times. So we end up with pi over 6. Here's another example, maybe 240 degrees. So again, I'm going to multiply by, I'm trying to get to radians, so pi over 180 degrees. Okay, so my degrees would cancel, and both of these are divisible by 60, right? So 60 goes into 244 times, 60 goes into 183 times, so we're going to end up with 4 pi over 3. And we'll do one more for good measure here. You can have negative angles as well, so negative 195 degrees. So negative 195 degrees. Again, we're going to multiply by that pi over 180. And the thing to remember here is that negative angles, right? All the negative angle means is you're going in the opposite direction, right? So usually we start with an angle here and then it kind of swings this way. Those are positive angles. When we're going the other way, right? So here's my angle and we're going down this way. If we swing this way, if we swing in a clockwise direction, that's all a negative angle is. So here I have negative 195 into 180, and I just punch that into my calculator. I take the 195 divided by 180, and I put it into my calculator and have my calculator give me a fraction back out. And if you don't know how to do that, I have posted in the Canvas shell information about the calculator. So this is going to be negative 13 pi over 12. Because if you plug into your calculator 195 divided by 180, you will get 13 over 12. So we can also go the other direction. So for example, we can convert the following radian measures to degrees. So for example, so maybe something like negative 3 pi over 4. So the thing to remember is, remember we said on the last page that 180 degrees is equal to pi radians, right? So this time I want to get back to the degrees, so I'm going to want the degrees to be on top. So 180 degrees divided by pi, and so if you multiply that out, you end up with negative 135 degrees. So one more of these, pi over 9. So again, multiply by 180 degrees over pi to get us back to the degrees. And this ends up being 20 degrees. And so that's all you have to do to convert back and forth.